thank you for having us here. And yes, just to solve that, BAUA is then just the German acronym for Bundesanstalt für Arbeitsschutz und Arbeitsmedizin. So German is a really very nice language. So not very well. Hi everybody. And well, also a very warm welcome from Patricia and myself. We will take the next 20 minutes to give our presentation on human-robot interaction and occupational safety and health, and what we know for the human-centered deployment of these collaborative robotic systems. So we are moving a little bit from the field of innovation in exoskeletons and move a little bit to the field of application of mobile robotic systems. We will present today some research that we had in a recent research project and in a current ongoing research project, Sophia, that we are also doing together with Arash, who's with us today. So we will give some insights from our research there. Yeah, Patricia, if you can go to the next slide, yeah. So the question. Okay, yeah, the question also why I said more application. I mean, we of course still do innovation and research here, but of course we are very close to giving policy advice, because that's our major role. As you can see here in the slide, we are part of the government authorities in Germany for OSH, and we are the research institute for the Federal Ministry of Labor and Social Affairs. And as such, we give guidelines, we work in standardization, we support regulation. So for us, it's always good to have field studies, to have technology with a very high TRL level, which already gets deployed, to learn something basically on the edge between the lab moving to the field, and then be basically up to date with everything, guidelines and regulation if necessary. And we do so, especially in the field of human-robot interaction. And well, we've prepared now four questions that we brought from our work at the Sophia project. And we want to talk in the field of human-robot interaction about what we know from theory. That's what you see here on this slide. We will take a look in what media says on human-robot interaction, what people expect. That's the major part, and Patricia will present that. And then we also state something on what we know for Europe in this technology field. So let me start here with what we know from theory. We brought you here the task technology fit. So that is published, that is known, that is knowledge that's out there. It's 1995, so quite some time, or quite old, but still valid. So meaning if you develop any kind of technologies that we've seen today, for example, for the exoskeletons, and if you want them to get used in an occupational safety and health context and occupational context in the end, it's very important to have this kind of task technology fit. And as you can see here from this model, that depends if basically you have to analyze the task characteristics. You have to, well, in this case, we can shape the technology characteristics. We have to take into account the individual characteristics. But still, if we all have these different characteristics collected and considered, there's still things from the user on beliefs, effects, precursors of utilization that still have an influence on the utilization and in the end on the performance that people have when using this kind of technology. And yeah, something before we start with what Patricia does on what people expect on the shop floor using robotic technology, maybe just 2 slides on the precursors of this kind of technology. What we have done, we've taken a look at headlines on human-robot interaction. This is now from 2016 to 2018, because these systems are not very well known on the shop floor by so many people. And according to the model that we've just seen, if I don't have any kind of experience, I build my opinion, for example, based on mass media. And what we can see here, we did some coding of the tone of these headlines, that in the years from 2016 to 2018, we had a slightly negative tone of human-robot interaction. You can see that on the next slide a little bit with the tech clouds that we've created. So on the left side, you see a tech cloud from the positive headlines. although still you see here the word steal is quite big. That was probably then in the meaning of robots are not stealing your jobs. And on the right side, you see, well, robots will take your job, robots will replace you. So this is yeah, something that of course implements, that has an effect on the people who are working on the shop floor. And when you enter the shop floor next day and you say, well, guys, we are going to implement a robotic system in the workplace, you have to have in mind when the media representation of this topic, at least in 2016 to 2018 with mass media that I've shown, was a more or less negative one. So people don't have, do not usually have a positive attitude towards this. Basically, that was very short theory, task technology fit, and well, what is the media representation? And we come now to the next part of our presentation, which is the core, which is what do people expect when they are asked and this kind of technology is implemented to the shop floor. And we are taking the results that we will just show from two projects. As you can see here, hybrid, that was national funded, and we have collected some data from Volkswagen and from Airbus, so from automotive sector and from the airplane manufacturing, and also from the Sophia project, which is ongoing. And also there we have automotive sector, automotive supply, and you will see the results in the following slides.
Okay, thank you, Sascha. I will take over here. Yes, so we in both of these projects, we are looking at mobile platforms. So within Sophia, we are also addressing exoskeletons. But what we will show you now are the results that we found out for the mobile platform. And just to give you an idea of what we are talking of, I just got this small video for you, which is a video one of our project partners in Sophia produced. So it's a simulation of a deburring workstation. I will just maybe forward it a little bit. So you can see the worker taking out the cylindric parts from the deburring station and the robotic device, which is a mobile platform, and a UR16 mounted on the top of the mobile platform is then bringing the cylindric parts to the deburring station. In this scenario, it is the worker leaves the workstation, but we have in mind that, for example, the person can do some additional tasks while the robot is working on the station. I will forward it a little bit more. And so, yes, here you can see the robot and the worker are working quite closely in the interaction form of coexistence or maybe cooperation, but also we here see no real collaboration because the worker and the robot are not handling the parts at the same time. But still they are in this scenario working together quite closely. And within the hybrid project, which has finished now, we had a similar scenario, as Sascha said, with VW and Airbus. With Airbus, we had a scenario where this kind of robotic system was helping to adjust some assembling parts in the wings, in the area of the wings. So just to give you an idea of what the scenario we are looking at, and also we use this kind of material for the work evaluation to actually address what people think and expect from their workplaces when they will be working with such robotic systems. And as Sascha has shown earlier, well, there is a lot of theory and a lot of models we can use if we want to analyze the interaction quality between human and robots. So there are different and many models with different concepts And it would be, if we had a lot, I mean, all the time in the world, we could extend questionnaires and use different measurements to ask a lot of different question aspects that could describe the human interaction quality. But of course, we are facing real world applications and companies which, first of all, do not have that much time to, so workers can't answer questionnaires well, for hours and hours. And of course, we also have some constraints regarding language, for example. A lot of questionnaires are quite complex from how the items are formulated. So there are a lot of different constraints we are facing when we are doing this kind of requirement analysis. So the first tackle we are dealing with is we have to kind of have to find a fitted approach of what we are actually interested in and what gains the most knowledge we can we can then use. And we have two major aims we're actually facing. So the first aim is that we want to get an idea of what people, what the workforce we are dealing with, what kind of people are they? And the second aim we are facing is what can we learn on how in next iteration steps and how we design the system, how can we design it in a human-centered way? And so therefore we address three different areas. So first of all, areas that relate to the robotic system. And here, of course, we can use usability as one of the core informations we can use based on the ISO standard 9241. This is a very, it's a standard which has been out there for a long time, and it was developed for software ergonomics, but it can also be deployed for human-robot interaction. So what we do is we first of all ask what people might expect in terms of usability of the system. But for example, when they see this kind of video, or they can also, when they just look at this type of systems. Furthermore, we address more issues that are related to the personal, to the individual. So we assess possible acceptance values, and also in the form of expected collaboration. For example, we ask people whether they can think of any benefits, but also potential problems in the short and long term when working with these systems. And then the third area we're looking at are task characteristics, because we know also from literature and theory that the working task, as Sascha already mentioned in the model you saw, the working task is the core element linking technology and human in the working system. So therefore, and of course, if we change the working task, then a core principle of the working situation will change. And one very important task characteristic is the amount of job control. So in the requirements analysis we use in the project, we do a pre-post comparison between perceived job control. And to give you an idea of what these expectancies look like when, so these are the qualitative results from VW in the hybrid project. We analyzed all the material. This was all qualitative material, and we categorized it into three areas in aspects relating to individual, organizational, or technical characteristics. And there were many more, but I just picked out some very striking results. So of course, I mean, we asked them to think of positive and negative ones, and luckily both aspects were, people were able to name both kind of aspects, but you can see quite strikingly, for example, on a individual level, people do expect improved physical ergonomics and a reduction of absenteeism also because of the improved ergonomics. But something that is also quite striking on the downside is that people, for example, do fear the surveillance of their performance. They say, well, these systems are then kind of capable to track how I work, to track how fast I work. And these are fears that have to be addressed within implementation processes. Also, the fear of job loss, which again, this is really in relation to what Sascha has just presented. Here we can see it might be the case that people that the expectations of people might be shaped due to their surrounding, due to newspaper articles they read, and it is a real fear they are facing, that they say this system could be the cause of my losing my job. And we see similar aspects which were mentioned by the workers within Airbus. Here we also see on the upside that both workforces, for example, also said that they would expect more task variety with the use of such robotic systems. And this is, and also the creation of new jobs. So maybe an increasing of qualification and an upskilling of jobs. So this is something which is seen as a positive effect, and which we also see as a good potential where these kind of systems could improve working situations. And here we see the results we've just very recently collected within the SOPHIA project. These are now the more quantitative data. So here we, as I said, we ask the people what they actually expect regarding usability from these kind of mobile robotic platforms. And it's quite interesting, first of all, that we see that within different companies, the different workforces expect different usability scores. So, for example, the suitability for individualization within company 2 and 3 is quite low compared to company 1. So the design recommendation here quite clearly would be that, especially for company 2 and 3, we should, within the project, take a or prioritize this dialogue principle in terms of or prioritize this rather to other ones. Because apparently people in company 2 and 3 do not expect this to be very high at all. But on the same side, the workforce in company 1 expects it to be very high. So therefore, because I mean, we can do a lot of work for each of the dialogue principles. But so not so that people won't get disappointed in company 1, and also that yes, they so sorry. So this could be a hint of how to prioritize further design iterations. Another quite interesting result we see here from the SOPHIA project are the results regarding the familiarity and experience with robotic systems. So we can see that the workers here are quite familiar with robots. However, working closely with a robotic system is not, they don't have that much experience with these kind of systems. So again, this is something we have to take into account when implementing the systems. Within 2 or maybe 5 years' time, this picture could look completely different. People might have gained a lot more experience, and then the whole introduction process should be probably designed completely in a different way. But at the moment, if we know that people might be a little hesitated, might be a little reluctant towards these systems, it's very important to have this participation at the beginning, and again, take into account that there might be some fears or some negative attitudes towards these systems, and not just say then, well, this is going to be there from next day on. So just to have really this worker perspective from the beginning on. This is something we can see quite clearly from these results. And last but not least, the results regarding job control. Here we have the different aspects from job control. I mean, we are in general within production scenarios, we're in a very standardized working task, so it's natural that job control measures are quite low. However, especially in company 1, we do see higher values in timing control, for example, and this is a good resource. This is a good resource, beneficial for workers' motivation, satisfaction. Some studies even indicate for the overall well-being and health. And the design recommendation that derives from this result really indicates that this amount of job control should be kept at any time. So the introduction of the mobile robot may not lead and under any circumstances to a reduction of, for example, timing control, because then we would lose a very essential resource. And therefore, yes, this is something we steadily monitor between the different stages we actually involve the workers. So now I've told you what people who will be working with these systems experience or expect in their future experience. And I will hand over now again to Sascha, who will tell you something about how many systems we actually find out there.
Yes, thank you, Patricia. I rushed through the last 2 slides looking at the time, but what we brought to you is results of the ISNA dataset from the European Agency for Occupational Safety and Health. So in 2019, they asked 45,000 establishments in Europe, and they had a specific focus on emerging technologies. And one of these was interacting robots. So we have this data from Europe, and we see on the next slide, that it's it's a technology that's out there. But if we go to the black bar, it's about 3 to 4% of the companies in Europe report that they do have robots that interact directly with workers. So they asked specifically for direct interaction. So not do you have a robot, because then we would have other numbers. We see it's somewhat below 1.5% in the minimum to Slovakia, which has more than 8%. Or reported 8%. If we go to sectors, of course, we find most of the robot in the manufacturing sector. It's like 12% average. So everybody who's interested, they have a very good website and they have data visualization, so you can take a look and go deeper into the data. Finally, what we have done with the data, they were also asked for associated challenges with human-robot interaction. Meaning, if they say, I have direct human-robot interaction in my company, what kind of risks do you discuss? And we did a binary logistic regression And here you see these significant results. So basically, if companies implement this kind of technology, they do have the challenge that people fear of job loss. I mean, that's now, you see it in media, you see it what people report, and you see it also here what the companies itself report. They report something on flexibility requirements that are higher there, which is a little difficult to explain. The strongest impact is seen in the need for training. If we implement this kind of systems, and also show associated risk with human-robot interaction. Close human-robot interaction are repetitive movements to consider. And sum it up, we have the concluding remarks. We have different theory-based models for the deployment of human-robot interaction available. It's still an emerging technology, although we know it for quite some time in research and in our labs, but it's not yet widely spread in practice. And from our point of view, it's very important to have the worker participation from the beginning. As you can see, we collect some data and we can feed that back to the system designers, to avoid that in the end, when the system is supposed to be used, is not used. And of course, what is important, to have a comprehensive approach. So not to ask for one specific aspect, but to consider task characteristics, to consider individual characteristics, to consider or to design technological aspects. And by that, we would kindly thank you for your attention. It's very late. Thank you very much. Thank you.
Thank you very much, Sascha and Patricia. Really, really interesting talk. I do have a quick question for both of you, just because we are a little, our next speaker is short on time. Do you mind if we put questions at the end of that? Perfect.
No problem.
Okay.